I'm going to move a little bit further afield from Cardiff now. So our next speaker is Vasilius Spathopolos. I've practiced this one. I practice them. The more I practice these names, the less chance I have of getting them right. Tony Thompson was easy. I can manage that one all day long. Vasilius Spathopolos, who's based in Glasgow. And Vasilius is going to tell us about the link between the history of astronomy and how we can maybe use Stellarium, which is a modern day computer program, to understand something about the history of the universe. We see you, Vasilius, and we see your slides, so you're good to go.
Fraser, you did really well pronouncing my name. Actually, Greek names are notoriously hard to pronounce. Yeah, my name is Vasilius.
I didn't manage to put the Scottish accent on top of it, even with a name like Fraser.
Well, I'm actually a Greek Scot, so I have a very long name and a bit of a Scottish accent as well. Right, so yeah, I'm Vasilius. Really want to thank the organisers of this amazing conference for giving me the chance to speak here. I'm based in Scotland at the moment, at the Glasgow International College. So most of the talks at this conference have been about the present and the future, but with this presentation to take you on a journey into the past. The talk that I will be giving is entitled Students Using Stellarium to Reproduce Measurements Made by Ancient and Medieval Astronomers. Okay. For some reason it's not responding. Can you hear me?
We hear you, we see you absolutely fine, but we're only seeing that first slide right now. So is it advancing on your screen?
Is that better?
Yes, presenter info.
Okay, sorry about that. Right, so first of all, a bit of information about myself. I actually have a background in aerospace engineering, so I'm not a professional astronomer, but as I will be showing in the next slides, I do have a great interest in the subject. I currently work for Glasgow International College, which is a partnership between a private company called Kaplan and the University of Glasgow. I teach science and engineering foundation courses, but I also have a great interest in science and engineering education, and I like writing, so I'm also the author of some textbooks in Greek and some popular science books in Greek and English. So I said I have an interest in astronomy. I'm a keen stargazer, Scottish weather permitting, which is not that often. In fact, for the last week, it's been hard locating the sun, never mind the rest of the stars. But because of interest, last year I created some astronomy-inspired activities for some of my classes. And this initial idea then led to a larger project, which is part of an Institute of Physics fellowship, which I'll be talking about. So a little bit of background to the project. The core idea was to combine the history of astronomy with planetarium software. And the software that I use is the software that's been talked about already in this conference, but I will be saying a few more words later on. It's the freeware Stellarium planetarium software. So I created some materials for my classes and were based on astronomical measurements and observations that were made by the ancient Greeks many years ago. In fact, if you're interested in this part of the work, I can refer you to a publication in the Journal of Physics Education. This went quite well, so I then decided to expand the materials and also include, apart from the ancient Greek, ancient Babylonians and medieval Islamic and Chinese astronomers. I presented this idea to the Institute of Physics, and I was lucky enough to get a small fellowship in the form of what's called the Anthony Waterhouse Fellowship. So why would you want to do something like this? Well, I think there's several advantages both for educators and for students. First of all, when using planetarium software, this means that the activities can be pursued without the need of using expensive observation instrumentation such as telescopes. Also, the package is freeware, so there's also no software costs attached. Now, one could say, well, you could teach this stuff using a PowerPoint, for example, but I think that the visual effects offered by the simulations add to the realism of the activities. I also think that including a in the teaching of astronomy increases student interest and motivation, and it also helps disperse with certain myths. We hear a lot of people nowadays talking about flat Earth. I think it's really good to let students know that 2,500 years ago, scientists, at least in ancient Greece, took it for granted that the Earth is spherical. Last but not least, my personal opinion is that especially here in the West, we don't emphasize enough the contributions of non-Western civilizations to the advancement of science and astronomy in particular. So I think it's really important that students, the contributions of civilizations such as the Islamic astronomers, the Chinese astronomers, the Indian astronomers, I think it's really important that they know about this. Okay, most of you will know about Stellarium, but I'll say a few words. It can be downloaded from this site here in a number of languages, and it can be used to simulate the motion of celestial bodies such as the stars, moon, and sun. Importantly, you can choose the observation location, date and time to obtain a view of the sky world as well, in the present, past, or in the future. So what were the project aims? Well, first of all, I had to perform some background research to identify suitable activities. I aim to design around about a dozen Stellarium-based activities, most of which have been created already, a few. These materials are uploaded to my own personal website, and once they're all ready, they will also be uploaded to the Institute of Physics website. And importantly, it's there for all educators, so any one of you can access them for free. I've also created a couple of short video demos, and if we don't have any technical disaster, I hope you can see one of them soon. So this is my personal website. You probably can't see much because the font is small here, so I've expanded. This is basically the same information on this slide here. This is a list of the activities. You'll see that there's a whole range. I start with recounts. It's one of the most famous works of literature. It recounts the adventures of Odysseus, or Ulysses as he's otherwise known as. There's actually a lot of astronomical references in the Odyssey, so I use those for an activity. Then there's a lot of activities on measurements made by the ancient Greeks. As you can see, the Babylonians were the first to be able to predict eclipses. The Islamic astronomers used different astronomical methods to determine, for example, the direction to Mecca. The Chinese did some similar things. So that gives you an idea of the activities. The first 9 that you can see are already on my website. I'm still working on the other 3. I hope to have them ready within the next few weeks or so. Before we move on to the next slide, I would like to pause a little bit and let us just contemplate 1 or 2 things. If we take, for example, the 6th activity here, estimating the distance to the moon. Now, Hipparchus lived over 2,000 years ago. He had no telescope, he had no binoculars, he had none of the technology that we have today. And yet he managed to figure out a way of estimating the distance to the moon. And in fact, he did it with reasonable accuracy. So the next time you go outside, you look at the moon, just think, this guy, more than 2,000 years ago, found a way of estimating the distance of that object from our planet. I think that's really cool, personally. Right, so I'm going to now try and show you a video. It includes two of the activities. The first one is the estimation of the size of the Earth made by Posidonius. A lot of you might be familiar with the method used by Eratosthenes. Another ancient Greek, Posidonius, used a slightly different method. And the second activity is exactly the activity that I was talking about Hipparchus estimating the distance to the moon. There's not too much analysis or description, but I wanted to show those videos to give you an idea of what Stellarium looks like and what it can do. So I hope it plays okay. Let's see.
Vasilius, we're not hearing sound if there's supposed to be sound alongside the video.
All right, maybe I'll stop sharing for a second and try.
When you go back into share, there's an option somewhere that says share sound as well.
Yeah, I forgot to do that.
All right, no worries.
Second. Okay, let me just go back to it. Okay. Give me 1 second. Can you hear it now?
Yep, that's all good. Yep.
Okay, I don't know what happened there. Can you see the slide now?
We're on a slide with Posidonius and Canopus.
Yeah, sorry.
Yep.
Yeah, there was a bit of a technical problem there with the video, but I think you got the idea. You can basically go back in time and replicate the experiments that those ancient astronomers made. So I'll just quickly go over the one by Posidonius just to give you an idea of how these work. He was a Greek polymath. He was born in the city of Apamea in modern-day Syria. He estimated the Earth's circumference by observing the position of the bright star Canopus when this star was viewed from Rhodes. Then it could be viewed on but never above the horizon. That Canopus
Vasilius, I'm not sure if you can hear us, but you're just freezing on us a little bit at the moment.
Okay, can you hear me now?
I can hear you now. As soon as I think as soon as you stopped showing that slide and telling us what was on that slide, you came back to us.
Right, okay.
I hear you fine now again.
Yeah, I turn off his camera to bandwidth. Okay, so.
Okay, yeah, that's a good idea. So I was saying that you can prove with some simple geometry that the two angles here, the difference in altitude and the difference in latitude, are the same. So delta phi, the difference in latitude between Alexandria and Rhodes, can be found just by observing Canopus from the two locations. This angle delta phi corresponds to an arc of length s, which is the distance in kilometers, we would say nowadays. In those days it was stadia, between the two cities. And then you can use a simple proportion that s corresponds to delta phi, L, which is the circumference of the Earth, corresponds to 360 degrees. You solve for L and you get the circumference of the Earth. So very simple, but also very, very smart method of calculating the size of our planet. Here the Stellarium Instructions. Just again, I won't go through them all, just to give you an idea. Students are asked to set the date to a day and time when Posidonius was around. They then set the landscape to ocean, just to add some more realism, because both Rhodes and Alexandria were ports, but it also makes it easier to observe Canopus as it appears just above the horizon. They then set the location first to Alexandria. They find the maximum altitude of Canopus. They then set it to Rhodes. They do the same thing. They find the difference in altitude, and they then use the formula, the simple formula that I showed you before, to find the circumference of the Earth. Now, this is one of the more simple activities, but I think it gives you the idea of how the whole thing works. People often require me often ask me what the requirements are for students. So no detailed astronomical knowledge is really required. Any elementary concepts, such as the altitude of a star, are covered in the activity notes. They do need, however, to have some basic maths and geometry skills. And I would say that the core activity notes aim at 15, 16-year-olds. But I do stress that it's the discretion of any teacher to modify those notes in order to challenge older pupils or students. So just to wrap it all up, a set of Stellarium activities are being developed. Most of them have been developed, actually. They simulate observations and measurements made by ancient and medieval civilizations, and they can be accessed by anyone at www.mysciencewalks.com. That's my own website. As I said, when they're all complete, they'll also be uploaded to the Institute of Physics website. This is my personal email. I'm happy to hear of any comments. I know, for example, that there are many Indians participating in this conference, and I would be happy, haven't been able to locate any suitable activities myself, but I would be happy to hear of any suggestions in order to include Indian astronomy as well in this set. A couple of acknowledgements. I would like to thank the Institute of Physics for supporting this project through the Anton Waterhouse Fellowship. And I'll get into trouble, though it didn't go particularly well with the videos, but I still have to say it. I need to thank my sister, Spathopoulos, for helping me create the video demos. Thank you very much for your attention. If there's any questions or any comments, I'm happy to hear. Thank you.
Vasilius, thank you very much. The videos did pretty much come through, and I don't think it was anything related to your sister's work that was stopping them coming through. I think it was a bandwidth issue. You kind of correctly predicted the one question we have for you, or two questions here, but the one we have for you for sure, which is from Amritanshu, and he's asking if you were planning on extending your work to Indian astronomers like Aryabhata and other Siddhantic texts, which have methods on eclipses, geodesy, and positional astronomy. So I think you've already sort of answered that in a sense that you're open to those ideas at some point.
Yes, I'm very, very keen other activities as well. The problem here is, well, there's two problems. First, you need to find the right resources, and for India, kind of more difficult for me to find resources in English. The second problem here is that you need to find books that are suitable to be adapted for school children to be able to understand. So, you know, it can be a bit tricky, but I'd be very happy if someone has any suggestions to include.
Okay, two more quick questions for you. We've just about hit a coffee break, but we'll just throw these in if we can. So Bonnie is asking if you can jump back one slide because she wanted to get your website details from the previous slide.
I think it's maybe easier if I just put it in the chat.
That's absolutely fine. That'll work for sure. Yeah, that's no problem at all. And then there's another question from Inga Teering, who is asking about saying about the idea of using Stellarium to go back in time, was just wondering what ages that you set, that you work with, what age groups and classes that you use this for.
Yeah, I mean, as I said, they can be adapted and modified for various ages. The core notes that are on the website, I would say, are for 15, 16-year-olds. But you know, you can make them more complex. I mean, I've done it for my students who are a little bit older than that. So, yeah.
Okay, brilliant. I think we'll leave it there. But thank you very much for your time and your presentation. Gustavo,